Here is a standard wing that comes with our kit. As you can see, this is a very close copy of an original bow-tipped Super Cub wing. We actually produce very few of these things. Most people like to go with the longer extended wing. But if you're the type of person that wants that classic 57 Chevy authentic Piper Super Cub look, this is the wing for you. We've got quite a few differences from original Pipers. Our spars, front and rear, we actually extrude ourselves. The outside dimensions of the spar are the same, but the web, which is the thickness in here, is 11th thou thicker than original Piper. These are all done from virgin 6061 T6 aluminum spars. Everything we use in our wings is good quality aircraft grade materials. We also, as I said before, extrude this outside rib profile. Then everything in here we manufacture other than the nuts and bolts, literally everything. We CNC machine all of our spars on a special machine, so we have accuracy down to the thousandths of an inch. Every time the same spar is always the same. All of our rib brace material is all cut on a CNC machine. All of our leading edge skins, basically everything on here is cut with a CNC machine in one fashion or another. The reason we do this is for ease of manufacturing on our part, but also we're able to keep our costs down to have a reasonably priced kit. One of the big differences over original Piper is you can see in our first bay here, we've got a 4130 chromoly steel tubing going through the gas tank, just like Piper did. Here's our gas tank back here, a little bit bigger. This is a standard 24-gallon fuel tank. So 48-gallon fuel capacity per aircraft. We do have some auxiliary tanks, I'll get to that in a moment. Big difference though is from here, Piper had what they call drag anti-drag wires. And they're basically piano wires that ran back and forth in each section, and they tightened everything up to make them square. Piper did that for one primary reason, is because 60 years ago when they were building these things, they didn't have CNC machines that were accurate to a thousandth of an inch. Now, we can cut these 3/4 inch square compression tubes on a CNC machine, and we can install them, and those will leave each bay square to within roughly 3/1000ths of an inch, which is for most people unmeasurable. That is accurate enough for what we need. We also find from some software we have that 3/4 inch square compression tubing has similar strengths to the drag anti-drag wires. You will notice in this second bay here, we actually do an X pattern. So we're achieving the same thing. The concern is if you only had one tube going through, that under a compression load, that tube could deflect to the side, so it could move sideways. When you have an X pattern, this can't happen anymore. Then after we get out to the next bay, we're getting away from a lot of the wind force, the prop wash, not so much force on the wing anymore. We're okay just to switch over to a single tube. And even here, the side loading is more than sufficient for what loads are being applied to the aircraft. Now, we have some auxiliary tanks if a person wanted. So, these fuel tanks, again, CNC machined, 50,000ths thick, 5052 aluminum that gets bent up, all TIG welded and pressure tested. We have yet to have a fuel tank leak on us over 100 plus flying aircraft, which is a fairly good track record. 48 gallons here, or sorry, 24 here, so 48 per side. If you want auxiliary tanks, we leave this bay empty. Then here we can go into a 10-gallon auxiliary, or we can even go to an 18-gallon auxiliary, which is what you see behind me. When we put the auxiliary fuel tanks in, we'll install a facet solid-state transfer pump here. So we're going to suck fuel from the rear of that auxiliary, dump it up into the front of the mains, and then you would normally feed off the mains. If you want, you can plumb these anyway. You can plumb it so you're feeding separately from each tank. That's entirely up to you. Another thing we do differently is our wing attachment fittings. So our root fittings on the spars and our strut fittings. Original Pipers had a stamped out steel fitting, which was weak in some points. So other manufacturers came up with a strap that went around the spar for tie down rings and what have you. We have this machined out of billeted 6061 aluminum, much stronger, and then we've also shaved out some areas for weight savings. These spars that we extrude are good for 2,200 pound gross weighted aircraft. This particular wing has an option of a spar doubler. They're installed. So these plates right here, this is 1/8 inch thick 6061 aluminum as well, and they are centered right on the strut attachment point. This is the weak pivot point. When you get a high lift load on the tip of the wing, from here, if that wing gets a high load on it, this is where it wants to buckle, is right down the center line of that strut attachment point. So by putting this doubler plate in, we really copied what Piper already proved with their Pawnee spray plane. Reinforcing this pivot point adds significant weight to the wing, and now we can safely go up to a 2,400 pound gross weighted wing with this option. It's not standard with our normal wing, but it's an option. Here you can see a close-up view of the doubler plate installed. It's all riveted in place with number 4 hard rivets. You can also get a good look at our strut pickup fitting. You can say we step down our fitting just to reduce weight, and it transitions the load down in the spar. You can also see we have a spacer plate that holds those fittings away so it can get around the spar cap. Those also have shaved out material because it's just a spacer, and anywhere we could possibly save weight on the aircraft. Also notice these are all yellow. They have a 2-part epoxy primer on them. This is an option as well. The standard wings just come bare aluminum. A lot of original Piper, or most of them, are all bare aluminum. I've seen them over 60 years old and they look more than acceptable. It might be desirable if you're going to be in a saltwater environment or a corrosive environment to do this 2-part epoxy, but if you're in a dry, arid climate, it's really not necessary. Now, with the original bow-tipped design, you can see on our flaps and ailerons, the flaps have 2 hanger arms, aileron has 3. The flaps are 66 inches long, and our ailerons are 102¼ inches. What makes our squared off extended wing so desirable is our flap actually has 4 hanger arms and is 10 feet long. Put a piece of tape here so you can see the difference. Here is our split on our flap right now. Our squared off wing, the flap comes all the way up to here. Then you can see that other piece of green tape over here on the floor. We go a full 17-foot long spar, so you get aileron from here out. You're farther out from the center line of the aircraft, so you get more leverage out there than you do back here. So even though your aileron is slightly shorter than the stock original, you actually have more controllability. Down at the tip of the wing, you can see the traditional bow. This is an aluminum bow over the original Piper wooden bow. If you did order a bow tip set of wings, the bow is already installed. Everything is put together for you. When you get the wings, all you need to do is you run your wiring for your nav lights and your landing lights, install the control cables that come with the kit, and it's ready to cover. The bow tip is somewhat of an inefficient design because as the wing tapers down, all that air just spills off the end. Our squared off extended wing comes out here, so we get this full airfoil rib profile coming out all the way to the tip, and then we have a composite tip that goes on the end. We now have a new efficient Horner style, it's got an upswept design, and it's not designed for low end characteristics, it's actually designed for minimal drag at high speed. So we designed it minimal drag at 100 miles an hour.